Hello children, I hope you have completed the concepts of the previous lesson. Now we are moving to a new lesson. Okay, so that is Unit 3, which is called as Solid and Fluid Mechanics. Right? So what are all the contents we learned in the last class? We have learned Newton's laws of motion and the related concepts like inertia and momentum. So you understood all those, right? So now with that content and remembrance, we are moving to the next one. In this lesson now, in this session, the current video, we are going to see about intermolecular and interatomic forces and the concepts of elasticity, plasticity, and how solids will behave like elastics. And there is one another model which will explain you how solids exhibits the property of elasticness and plasticness. Okay. First we have to know what is matter. This you have been learning from your lower classes. The substance which occupies space and volume. For example, this is your space, right? There is what is the place available here is called as space. In that space, I am occupying this area, right? So I will be called as one solid matter with respect to this, right? So for example, scale here. So in this space, this scale occupies one small space over here, and it will have some mass also. So like this, any body which will occupy space and volume is called as matter, and it is classified into 3 types: solids, liquid and gas. Till now you know like that only. Now one another state gets added up, which is called as plasma. Plasma, I tell you that it is an ionized matter of a nuclei. Nuclei means before you would have learned about atom. Atom, I tell you a simple part, right? Simple example. This chocolates, example. Okay. Now if I break this, right, into smaller and smaller pieces, the last undivisible part which we cannot see through our eyes, it is called as atom. Right? This atom will have so many parts inside. In that, the central part is called as nucleus. This nucleus and atom consist of 3 particles called protons, neutrons and electrons. Okay, and these are called getting the charges known. So these protons, electrons and neutrons will have some charges, will have some energy. Protons will have positive charge, electrons will have negative charge, and neutrons will have neutral charge. And getting the charges, so that process is called ionization. So these ionized charges, the atom existing in charged state, that is called ionized state. That state is called plasma. Now, as of now, this alone is enough for you. As you grow to the higher classes, more details you will learn. Okay, right. Now, this fluids. So, what about this word, children? Fluids. Solid you know, liquid you know, gas you know. What about these fluids? Anything which flows. Flows means what? Moves from one place to another place by itself. Liquid or gas, it will move from one place to another by itself. For example, if there is a gas leak at your house, even from your hall you can feel the smell, right? So gas from one place to another place moves, flows. Your incense stick, in Tamil we say that to be moodvati, no? Right? So that smell you can get from your puja room even to your hall. So that flowing, that is gas which is flowing. Liquid also, if you flow into one place, it will flow to another place, right? So that substances which can flow from one place to another by itself, they are called fluids. So these 3 matters, liquid and gas, are called fluids. These fluids, either liquid or gas, it will take up the shape of the container. Right? In water bottle, if you pour water, the water will take the shape of the water bottle. Right? And gas cylinders if you have. Right? So your LPG gas cylinders means the gas will take the shape of the LPG cylinder. Auto cylinders you would have seen, so it will be in brownish black color. Right? So if you fill gas in that cylinder, then the gas takes up the shape of that particular cylinder. So whether it is liquid or solid, where it is kept and what, depending upon the temperature, It takes up the shape of that container, right? Why this property happens? This is because of two properties. These are these two. Interatomic and intermolecular forces and agitation due to the temperature. I will explain you this to you. See, I told you what is atom, right? If I break this into smaller pieces, you will get the last undivisible part to be atom, and this matter consists of so many millions and millions of atoms together, right? This atom combine together to form molecules. Okay, atom, the last undivisible part is called atom, and atoms combine to form molecules, right? So now what I was saying, the liquid and gases take up the shape of the container at one particular temperature. What is the reason? That is what I asked now. So first reason is interatomic distance or interatomic force or intermolecular force. See, there will be so many atoms in this, right? So between one atom to another atom, there exists some force in the center, right? So that force between the atoms, one atom to the other atom, nucleus of one atom to the nucleus of the other atom. For example, I will tell you children, so if this is going to be your atom, the central part is called nucleus. So like this, another atom will be there, another nucleus will be there. So the force between atom and atom, nucleus of a nucleus, and around this there will be electrons flowing. So electrons and electrons. So whatever may be the attraction between one atom to the other atom is called interatomic forces. And now how this interatomic force will change? If it is due to the temperature change. If temperature is increased, now what will happen? The molecules or atoms over here will get agitated. Agitated means it will get disturbed, and it will try to move from its space. Where it is occupied, it will try to move. Right? When it moves from it changes from its state. If it is going to be solid, it will be moving apart. When this will happen? When temperature is applied. Then it will become liquid, and even then, if temperature agitation is increases, then the liquid will be converted into solid. Right? So that is why I said temperature is also a reason. If temperature is not changed, solid will remain as solid, liquid will remain as liquid, and gases will remain as gases. Okay? So this two is very important question. A good example for this is water. Right? If you take ice cube, right? So when you eat the ice cube or you keep it there from the fridge, right? It will take up the heat from the atmosphere. What happens? The intermolecular force will be increased, right? So what happens? The ice cube will become water. Solid state converted into liquid state. Now, till if we boil the water, what will happen? Water will get evaporated. Now, liquid will move into gases. Okay? So, due to this temperature and the force, if the force increases, the repulsion also will get increases. So, like this, these are the two reasons why the fluids will occupy a fixed volume. Right? Now, what are interatomic force and intermolecular force? I told you the forces between the atoms and the molecules are called interatomic forces or intermolecular forces. These forces are of two types. One may be attractive force and one may be repulsive force. Attractive force is nothing but, are you following the video along with the textbook and pencil in your hand? Wherever I am crossing, just underline that in your book. Attractive force and repulsive force. Attractive force is the force of attraction between nucleus of one atom with the nucleus of another atom, or atom of one substance with the atom of another substance, or electron of one atom to the electron of another atom. Right? Now this attraction means what? Two atoms will come close together. Then only it is called attractive force. Now during this attraction, your distance gets decreased. As distance gets decreased, potential energy will also be decreased. Now, when it is a repulsive force, repulsive is moving apart. If it is a repulsive force, nucleus of another atom, or electrons of one atom is electrons of other atom. If it is going to be repelled, the distance between two atoms gets increased and the energy, what energy? Potential energy also gets increased. Okay, so that is what here I have to discuss over here. And usually children, the universally, any two substances, for example this board and me, take these two. Always there is a tendency to have the, what is that? Minimum potential energy. Minimum means what? It will be attractive force or repulsive force? It is attractive force. Then only distance will get decreased. So potential energy will be more. And this potential energy, if it is minimum, stability will be more. Stability will be more. So know this. Distance less, potential energy is also less, stability also will be more. Okay? So keep like that in your mind. Now, this interatomic distance is for solids, if it is taken to be R naught, are subscripted by small 0, right? If it is R naught for solids, it will be greater than R naught for liquids, and it will be very greater than R naught for gases. Very simple children. Interatomic, the distance between the atoms in solids will be a smaller one. They are tightly closed, right? For liquids it will be little higher, and gases it will be more and more when compared with solids and liquids. That is what I have written over here. This point is very important for your cylinder class. Right. What is this interatomic force? So it is the force between atoms, which includes electrostatic attraction between charges of atoms. So this is what I told. The central part is called nucleus, and the surrounding they will have, atom will have electrons. So what are the three particles I told? Protons, electrons, neutrons. Protons will have positive charge, electrons will have negative charge, neutrons will have neutral charge. And this charges, they will attract or repel with another atom, right? So if this chocolate, if I take one atom may be here, one atom may be here, right? So the attraction or repulsion between these two atoms is called as interatomic forces. This electrostatic interaction is the interaction between the charges. Electrostatic means it refers to charges. Protons, electrons, neutrons, positive charge, negative charge and neutral charge. Okay, respectively. Right. Now, this interatomic force will be active, will be very strong if the distance between one atom to another atom is 10 power minus 10 meter. Right? If two atoms are here, see I have drawn a very bigger way, right? So 10 power minus, so it is very smaller, right? So you know that minus means it will come in the denominator, right? So it is, only when the distance between two atoms is 10 power, one atom is here, another atom is here. I am saying in a macroscopic way, and I am explaining here in a microscopic way. Right? One atom to another atom, the distance must be 10 power minus 10 meter. Do you remember this 10 power minus 10 in your first lesson? Angstrom, right? If it is interatomic force, the value must be 10 power minus 10, and it should be of this order, right? And next one is, if it is intermolecular force, it must be 10 power minus 9 meter. If it is other than this value, right? If the interatomic force or intermolecular force is not of the order of these two, then interatomic force or intermolecular force will not exist. Okay? So they are electrical in nature. They are electrical in nature means what? They will have plus charge, minus charge and neutral charge. If charge comes into scene, there it will be related with electrical nature. Right? Okay, now you come to this similarities and dissimilarities between these two forces. What are the forces? Interatomic and intermolecular forces. These two forces, interatomic and intermolecular force, I have written here as IEA and IEM. IEA means interatomic, IEM means intermolecular. Now, what are these two? What are the similarities these two forces have? They both are electrical in nature. Electrical means what I told you, charges it will have, right? And they are active in short distances. Only when they are very short, only when the atoms are too close to each other, they will be highly effective. If the atoms moves far and far, if the distance increases, interatomic force or intermolecular force does not have any effect, or it will have less effect. Right? Now, there are two graphs in your book, children. Just refer to the pages. Two graphs in your second page and your third page of this lesson. You can find two graphs. One is for intermolecular force and one is for interatomic force. The two graphs will look the same. Alright? So, you don't worry about that graphs and all. This point are known as input. Right? So, about that graph you will learn in your higher classes. Right? So, this force distance graph will be same for both the forces, and this is what I have told you now. Here I explain no. Only when it is of the order of 10 power minus 10 or 10 power minus 9 for intermolecular and 10 power minus 10 for interatomic, they will be good, appreciable, stronger way. If it changes, if it goes outgoes this limit, that will not have any effect. That is what I had explained here. It will be attainable and strong only if it has certain value, and it will be repulsive if it goes out of that value. Right. So that is what I explained here. What are the dissimilarities? Interatomic force goes for atoms. Word itself says interatomic. Intermolecular force goes for molecules. Atoms combined together is called as molecules, I told you. So interatomic force means it is the force between atoms, and intermolecular force means it is the force between molecules. Right. Now another point I told you, interatomic force is very greater than intermolecular force. 50 to 100 times they will be greater. So it is a very important point, children. So please underline it. Right. Now coming to solids, it will have two properties. Right. One is elasticity and another one is plasticity. Say these words: elasticity and plasticity. Right. So ELASTICITY, PLASTICITY. Right. Elasticity, plasticity. What is elasticity and what is plasticity? For that I have a ball here, a rubber ball. Right. Now I am going to apply a force here. Right. This ball we have been seeing for 2 classes. Right. Same ball. Listen to me. Right. Now I am applying a force. So this is a body. Right. Now I am applying a force. Right. Now is the body getting a change in shape? Yes, it is getting compressed at the sides. Right. Now if I take the force out of the ball, right, now it is regaining its shape. So the shape doesn't change. Right. So this nature, when applying when applying a force, body undergoes a change. On taking away the force, the body comes back to its original position. That property, returning to original form on removal of deforming force. The deforming force, the meaning I will tell you again. Right? Afterwards I will tell you. So this nature, regaining its original form. You all kids will play with rubber band, no? Right? So you will have bow and arrow, right? So you stick it out, you will what is that term? You will stretch the rubber band, and when you release it, the rubber band will come back to its position, right? So that nature, when you apply a force, the body changes its shape and size, and when the force is removed, the body comes back to its original position. That property is called elasticity. Right? Now the force I apply, no children, here I told, the force I apply through my hands, that force is called what? Deforming force. What force? Deforming force. Okay. If a body retains its original position, it is elasticity. If a body doesn't retain its position, for example, now here, if I have a stone, right? If I have a stone of this shape, right? When I hit it with a bigger force, right? The stone will go into smashes. Why to go there? Now this same ball, more than my hand force, if I apply with a stronger force, right? With a hammer or with a pricker, so So the body will get deformed. In that condition, the body does not regain its original shape. So that type of body is called plastic, right? So now this ball I can take an example, right? This ball, if I smash it with a hammer, right? So this ball can, what is that? Go out of its shape. So then that type of losing its structure is called as what? Plasticity. Okay, right. Now you come into the next point. So elasticity over regaining means elasticity, not regaining means plasticity, and the force which changes the size, shape and size is called as deforming force. If the force changes the shape of a body, then that type of body is called as deformed body. Okay. Now I'll tell you another. I'll ask you a question, right? Now I'm pressing this body. What force am I giving? Deforming force. Now it is regaining elasticity. How this regaining happens? Now this ball will have so much of atoms, right, inside. Now when I press it, the body gets a bit deformed. But when I take away my force, what will happen? One force will act inside the body, which will push the body back into its position, right? That pushing back force which acts inside, no. So that force is called as restoring force. The force which brings a body back into its position is called as restoring force. Now we have another term called perfect elastic body. For this I have a ball here, right? A small ball, a rubber ball only, but a little stronger one, right? Now I have this, right? Now when I press this, right? See, now I give the force here. Now it doesn't even bend, right? So now this body doesn't show any tendency to change its shape, even on applying a bigger force, right? Now I am applying, see here. So now I am applying a big, it doesn't even change in its position, even a smaller way, right? So but this force, right? Now if this ball, if I apply the same force here like this, it shows some change. It shows some change in its structure. But this ball, even if I apply a stronger force, it doesn't even show any tendency like pressing or compression. So that type of body is called perfect elastic body. That it will remain unchanged. Whatever you do, whatever force you apply, it remains unchanged. Like a stone, right? So that type of body are called perfect elastic body. So that is what I have shown here. A body regaining its shape and size immediately after removal of deforming force. Once I apply and remove my deforming force, the body will be in its position immediately. Then it is perfect plastic. If it comes back, it is elastic body, right? So that is called, all these terms are very important. The actual definitions I have given in your notes. Okay. So what are the concepts we have learned? Elasticity, plasticity, deforming force, deformed body, restoring force, perfect elastic body. Right. Now coming back to this perfect plastic body and perfect elastic body, I have told you. Perfect elastic body means what? A body immediately gains its shape. Perfect plastic body means even after removal of force or applying the force, the body will never have any tendency to change its shape. So like one small ball I told you, no. So it is a perfect plastic, right? So this will be, what is this? Perfectly elastic, right? So little difference only, children. Elastic means normally it will come. Perfect means immediately it will come. So the timing alone is important. Okay. Now elastic behavior of solids. How this elasticity and plasticity happen in solids? Very especially in solids. Right? How the solids will have atoms here and there everywhere in the body. Right? So there is one theory. The atoms are arranged like this. Right? Now it will be arranged like this, children. I will show you in close-up, right? So like this, solids are arranged at corners of cube-like structure. So that is what I have drawn here. Like a cube, the solids atoms are placed at every corners. Now, even after applying a force, if one atom is removed, what will happen? The other atom will attract it, will apply the force on it and bring back to its original position. So that's why, what is that? Even when a body is, what is that? Change its shape, the other atoms will attract it towards its position and it will attain the original shape. So this is called elastic behavior. Now there is one model explaining you this. This is what I had explained here. Spring ball model. Now the solid is just like a spring structure. Right? So now the balls are, this diagram is also there in your book. Right? You can refer to that also. Now the solid atoms are arranged at the ends of the springs. So springs are, you know children, if you press like this, it will get compressed. If you release this, it will get expanded. Right? So like that, now spring ball, see now if one atom is hit, so it will get compressed. On applying a force, it will get compressed, deforming force. Now restoring force will happen and it will get expanded. So this structure makes the solid to behave like elastic or plastic. So what are the two models I told you? Elastic behavior and spring model of solids. Now last one is very important. How much a body can be elongated or compressed. If I apply more force or if I apply a more repulsive force, body's deformation will be more, elongation will be more or compression will be more if I apply more force. If the force is less, deformation or elongation is less. So note down this children. So very theoretical based concepts only. So very few formula based and calculation based, analytical based concepts will come in this lesson. So very easy to learn well, complete the classwork. We will meet in the next class. Thank you children.